Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll take a look at the input buffer component, which allows us to store input action presses for a limited time. Now, designing components can be as easy as asking three important questions. What is it that this component does? What data is needed for the component to do its thing? And finally, how does it communicate with the outside world? Now, what is that one thing that an input buffer component does? Well, it captures and holds an input action within a short physics-based timed window. This can be useful, for example, for preventing eaten inputs, such as pressing the jump button 0.1 seconds before landing and allowing the player to jump. This can add a lot to game feel. Now, what data is needed for the input buffer to do its thing? First, it needs an action name, which is a string name, and this will be the input action that the component is listening for. These can be set inside project settings and input map in Godot. Second, it needs a float for the buffer time, which is the time window where we still want to allow, for example, the jumping to happen. This should generally be somewhere between 0.1 and 0.2 or 3 seconds. And finally, how does the input buffer component communicate with the outside world? We provide two public methods for outside communication. The first is called isBuffered, which is a Boolean method, and it returns true if the action was pressed within the valid buffer time window in the current frame. And the second one is called consume, which clears the buffer window immediately. This should be called by whoever handles the input management for that character or for that object immediately after using the buffer for the desired action. This will help us to eliminate weird edge cases where a double action would be executed because of the buffer and the usual non-buffered input action as well. So practically, the input buffer handles all the inside logic for executing or opening that time window. But for this to be useful from the outside, we need to use those two methods. Now let's move on to implementation. First, a custom icon is provided which makes the component feel like it's part of the Godot ecosystem when you add it to the scene tree. Then a custom class name is set, and the class is extended from the base node class. Then we have two export variables. The first is the input action for this buffer component, which is a string name. These can be found again at project settings and input map. The second export variable is for the buffer time window, which is given in seconds with a float, and it defaults to something like 0.15, but can be anywhere between 0 and 0.5 seconds. I think anything above that sounds a bit non-practical. And then we have a private variable called buffer timer, which is again a float, and this is the current remaining time for the buffer when we start buffering after the input press. Now, how and when do we start buffering? We override the unhandled input built-in virtual method, which passes an input event as a parameter, and we check if the registered input event is the action that we are listening for with this component using the action name export variable. And if it is, it means that we need to open this buffer time window, so we assign a new value to the private buffer timer variable, and we start it with as many seconds as we defined it in the buffer time export variable, right? This is essentially starting a new buffer timer whenever the input action is pressed in the game. Now, how do we actually tick down that timer? So we override the physics process method as well, and what we do is we check if the buffer timer is currently running, meaning that is greater than 0.0. We need to subtract the delta time from it. Why the delta? Because if you think about it, the delta is the times elapsed between the last two frames, right? And it's usually given in seconds, so we can use it as a float, just as is. Now, why the physics process method and why not the process method? We could use both, right? My reasoning here for the physics process is that usually this input buffer is tied to movement logic, right? Like jumping or executing combo actions or something like that. Some actions that have to do something with the physics system, right? So essentially by using the physics process method, we tie this whole counting logic to the physics ticks. And it means that when we query the buffer timer, we know that the last change for the buffer timer happened during a physics frame because it's tied to the physics process method, right? So we can execute actions immediately, and we know that those actions will be synced to the physics system that way. And finally, we have to do the two public methods. First, we have the isBuffered method, which returns a Boolean value. And it's really easy to know if we are currently in the buffer time window or not. We just need to check if the private buffer timer variable is greater than 0.0. If it is, it means that we are currently inside the buffer, so we can execute whatever action we want to. Again, these actions will be executed and managed by someone else, not this component. This just tells the outside world that, hey, this buffer window is currently open or closed, so you can execute or cannot execute the action you want to. And finally, we have the consume method, which is a void, and it's just used to manually set the inner timer to 0, meaning that we quote unquote used that buffer that we are currently running. So this needs to be called immediately after using the buffer in the outside to make sure that we cannot execute the action twice or 2 consecutive frames. And with the implementation out of the way, let's see it in action. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So I have the project open here, and let's take a look at the scene setup first. So we have a character body 2D for jumping with an animated sprite 2D, a collision shape 2D, and an input buffer component attached to it. For the animated sprite, we have a couple animations. We have an idle animation like this. We have a jump animation when the character is jumping, it's just 1 frame, and we have a fall animation when the character is falling down. Also, we have some background and tiles, it's not that important. We have a collision shape, and the tiles for the foreground also have a collision shape to them, so the character cannot fall down. And we have also a bunch of UI nodes. We have 3 buttons for changing the engine timescale, which can help us slow down the whole thing so it's easier to see how the buffering works, because it can be quite fast at normal speeds. We have a label for showing the current buffer time that we set for the component, and also a slider which can change the buffer timer so we can see it in action. And there's also a disabled button for sort of just a status message or some instructions. It says press space to jump, but when we do jump or when we press the jump button for buffering, it will display the remaining buffer time from the timer so we can see how much time we have before we can jump again. And the input buffer component itself is configured with these 2 export variables. We have the action name and the buffer time, and the action that we are using in this example is called fire, because that's what I have set up in the project settings, and for the buffer time I just set 0.15. And if we go to project and project settings and input map, indeed we have an action called fire here set to the spacebar button. Now, as you can see, we have no other scenes that we instantiated here because we have no open as scene icons here, but we do have a script attached to the input buffer, so the root node handles everything in this example. So let's take a look at that script then. And here we have a bunch of code, but it's not that complicated, I promise. So inside ready, when the whole thing loads, we have a bunch of signals to connect to. The 3 buttons for setting the game speed use this set speed method that is defined just here. It takes a float as a parameter and sets engine.timescale to that speed, and we just bind the parameters to the buttons. The first one we'll set it to 25%, 50%, and 100% respectively. We have the buffer slider, which has a value change signal when we move the slider, and what we do in this case are 2 things. First, we change the buffer labels text so we know the current value we set for the slider, and we also grab the input buffer component and change the buffer time export variable to that value as well, so we dynamically can change the buffer time when we are running the demo. Now, we already talked about set speed. Let's see what we do each frame. So here we just update the status button text, and we use the input buffer component for that. We check if we do have a buffer running currently, and if we do, we display again the remaining time. It looks a bit ugly. I know I already said this, but these demo codes are not meant to be the most beautiful implementation. Here you can see that it's pretty weird that I have the input buffer component referenced here, and after the dot we have an underscore, and this is because the buffer timer variable is meant to be private. If we take a look at it, that's why it has the leading underscore, so you don't write ugly code like this. But just now, for debugging purposes and displaying it, I do use it like this, but you shouldn't, and that's why they are considered private, you know, when we attach that leading underscore, but it does work. So there are no private variables, so to speak, like in other languages, but it's just a convention that these variables shouldn't be used like public variables, which again, I kind of violated here, and it looks ugly as well. It's a telltale sign. But anyway, it works for the demo, so I don't really care. And for when the input button is not running currently, we just change back the status button's text to press space to jump. And the important things are happening with the physics process method which is in sync with the physics engine. And first we'll call two methods one after the other. We have handle gravity, handle jump. Then we call the character body 2D's move and slide method to move it with its current velocity. And finally we call another method called handle animations. This is just a very basic jumping logic, but let's take a look at those private methods one by one. So how do we handle gravity? We take the delta time and we check if the character is on floor or not. This method is provided by the character body 2D class. So if the character is not on floor, then we take the current y velocity of the character and add an arbitrary number to it multiplied by delta. This will make sure that the character falls and the gravity force is applied to it and it accelerates, hence the plus equal. Gravity is this simple. Now probably the most interesting one for this demo and this video is how we handle jumping, right? So there are two different cases when the character can jump. For both of those cases, the character has to be on the floor. But it can happen that the character is on floor and on the same frame or in the same frame, we press the jump button. That's the kind of easier or more natural way to execute a jump, right? If the character is on floor, I press space, it jumps. Simple as that. See, the thing is, it sometimes can feel as unresponsive to the player because it might happen that the character is not on the floor yet, like let's say it's somewhere around here, and one frame elapses and in the next frame it will be on the floor. And to the player, this is a very small difference, right? So for the player, it feels like they press the jump button in time. And if you don't execute a jump, it feels unresponsive. So that's what buffering is useful for. So the first case is the easier one. The character is on floor and jump is pressed during this frame. And what we add to this sort of is not just if the jump was pressed, but was a jump buffered, right? Is a buffered timer window currently is running for jumping. And we can query the input buffer component for this information. So we just say that if the input buffer component is buffered, public method returns true, and we are on the floor. So that's the second case, that we are on the floor and we didn't press jump during this frame, but there is a jump that's buffered. Then we set the velocity's y component to negative, hence we are moving upwards and executing the jump. And what's really important here is that we call the input buffer's consume component. It doesn't really matter if we executed the jump because we pressed it on the right frame or because the jump was buffered. We want to reset the input buffer both cases just to be sure that we don't do an accidental double jump. Right. And that's about it for the jumping. And finally, after moving the character, we handle the animation that should be played. And it's a pretty simple logic because we just have three kind of animations we can play. If the character is on the floor after moving it, we can play the idle animation. If it's not on the floor and the velocity is a positive value, then the character's falling, so we can play the fall animation. Otherwise, we know that it's not on the floor and it's not falling, so we can play the jump animation. And that's about it. That's all the code we need. Hopefully it makes sense. Now, if we run this scene at normal speed and 0.15 buffer time, it will be pretty hard to see, but I press space to jump and press it again. And you see if I press it mid-air, you can kind of see here that the timer runs out, so there's no jump executed when I land. And let me slow it down to 0.25. So if I jump and I press somewhere around here spacebar, you see the timer's running out, and even though I'm not pressing space when the character lands, the jump will be executed again. But you see if the timer runs out, there's no jump, but if the timer remains when the character hits the ground, there will be an extra jump executed. Now we can of course make it much more crazy, like 0.5, and in this case, even if I press space somewhere around here, a jump will be executed. And I think this feels too much. So with this buffer timer, you kind of want to be cautious because it also feels unresponsive if it jumps even though I press space mid-air for whatever reason. I don't want the character to jump after that many seconds, right? It feels weird. So you really have to tweak in these parameters. Now if we set it back to 50%, you can sort of experiment with these values, what works and what doesn't for your game. Now, before wrapping up the video, let me show you how it looks without the input buffer enabled. So let's leave it at 50%, and if I go to the remote scene tree and search for the input buffer component, let's just set the process mode to disabled. So this means that the input buffer component shouldn't work now. And if I press space, you see that the button doesn't change. And if I press space when the character almost lands, like right here, you see it wouldn't jump. And this feels unresponsive to the player, right? Because even though it's fair, like from a developer's perspective, it feels like I press the jump button, the game is unfair to me because it should jump. It feels unresponsive. With the input buffer enabled, if I turn it back on, it feels much more fair to the player, even though it's not. And game designers always say that we should cheat in favor of the player. So this feels like a small thing to do, but it can change a lot. And it's also a very versatile component in a sense that you can use it for example, combo-based attacks, for action games, for jumping, for dashing, things like that, right? And that's pretty much it for the input buffer. Hope you liked it, and I'll see you in the next one. Bye-bye.